Good morning, everyone. Today, our group would like to present our idea, which is a Malaysian food detector. We have a scenario that we want to know the food calories that we eaten, very convenient and fast from taking the photos. So we want to have a system which can tell us what is the food calories of that food. So we use image classification, a VGG16 network to help us to classify the image of the food. So our idea is we can build a mobile application after the user have taken the photo of that food. The VG network can tell us what is the type of the food. In this training example, we use Kaggle Malaysian food, which has 11 classes of food. It is a small scale training, but it is a good start for us to train our network. VGG16 is the winning network in 2014 in the ILSVR competitions. It has consistently used a series of 3x3 convolution kernel, and it has used the mass pooling layers in its architecture. Then it has 3 fully connected layers at the end of the architecture and use a software activation function to classify the image. The original VGG16 have 16 layers, but for our fine-tuning purpose, we have frozen most of the layers, but we changed the last 2 layers. Then we have refer the data vec, the load image, and also the actor classifier in the training lab examples. We load the image, then we do the image transform, we pass it into the record reader and trained by the VGG network. We also fine-tune the network and build the computation graph. Lastly, we test the results and connect to an API.
This is the result of our evaluation performance. So the train accuracy is 0.91, which is quite high, and the test accuracy is 0.79, which is very less than the train accuracy. And the F1 score also 0.79, which is the overall score between the precision and recall. The confusion matrix of our classes contains of 11 classes. The first is fish and chip, fried noodles, fried rice, hamburger, kaya toast, laksa, mixed rice, nasi lemak popiah, roti canai and satay. This is the confusion matrix for the true positive, true negative. The strength of our project is we have a good architecture to classify the food dataset, because we use the transfer learning, which is very flexible in allowing the use of retrained models directly as a feature abstraction and integrated into entirely new models. So the weaknesses contain many weights parameters from the pre-trained models, which is the VGG. And then we have a heavy model because it takes almost 6 hours for 3 epoch in our coding to run. And the last weaknesses is we require more fine-tuning to achieve higher accuracy, more than 0.79. So in the next slide, contain the Fat Secret REST API, which use HTTP requests to access and use data. This is the largest database of verified food and nutrition data. Also contains recipe per meal builder and material analysis capability. It takes up to 5,000 API calls per day, but have limited local delicacies in database such as popiah. So the next slide I will pass to Vimal.
Yeah, hi. Right, so I'd like to talk about the API methods that are used for the Fat Secret API. So the two main methods are the food search method, which looks up the food name based on the model's prediction, right? So this returns a list of foods for that specific food name. And what we do is that we take the top result, and we get the ID for the result, and we pass it through a get food method, which returns the information for that food. So the kind of information that you get for the food is the nutritional value of the food, like calories and protein, carbohydrates, and fats, as well as different types of fats, such as trans fats, and it also allows for different measurement units, such as the metric unit, and general units such as cups and packages. Right, as you can see, this is just running, loading the data and the model.
You are doing a test, or are you testing one image?
Yeah, we're testing an image here.
Okay.
So we test right now. It's gonna display a webcam stream, and it will recognize one of the foods, actually two of the foods that I'm about to show it, and then return the nutritional details for that type of food. I didn't have the food accessible to me, so I had to use an image, Google image search. So this is fried rice. I'm showing it right now, and it should predict it as I press enter. As you can see in the prediction, fried rice, bottom left, and it shows the nutritional value, calories, serving, protein, carbohydrates, and fat. There are more details available, but I didn't want to display all of them. Yeah, and this is the details for laksa. Right now, this currently only works on the PC. One of the limitations of our current model is that it only includes 11 types of food. So we want to include more food in the database, but the images have to be sourced. We need about roughly 1,000 images per class. And so as you add more foods, your database actually gets quite big. We have a plan on developing a mobile app for users to use, but due to the large size of the weights of the model, this would probably have to be stored on a server, which would connect to the app instead of being stored locally on the device. We also plan on adding a tracking system for the calories consumed every day, so that people can actually add individual profiles that tailor to their needs. So the conclusion is that this application is actually quite useful and could actually help Malaysians detect the calories and amount of food that they consume daily in a very convenient manner. It helps them keep track of their food and the calories consumed every day, which would reduce the obesity rates in Malaysia, which is actually quite high, one of the highest in Malaysia. And this would in turn, help people maintain a healthy body and prevent the risk of being obese. All right. Thank you.